For this question, we want to graph the system of linear inequalities in two variables. Our system of linear inequalities is y is less than negative 2x and y is greater than negative 7x. When we're graphing a system of inequalities, we want to graph each individual inequality on the same coordinate axis. So we're going to start with the first inequality, y is less than negative 2x. And when we graph an inequality with two variables, we want to start by graphing the boundary. And the boundary will replace this inequality symbol with an equal sign. That's y equals negative 2x. And then once we have our boundary, we need to decide whether to graph that boundary in a way that includes the boundary or graph it so that the boundary is not included. The inequality symbol that we have is less than, which doesn't include equal to. So we're trying to draw the inequality y is less than negative 2x, and the boundary is not included because that inequality symbol doesn't have an equal to. So we want to draw the boundary so that it's not included, and the way that we do that is with a dashed line. So the boundary line being dashed will indicate that the boundary is not included in the solution set. Now this line is a linear equation, y equals negative 2x. It is written in slope-intercept form, y equals mx plus b. So we know that this line has a y-intercept at 0, and we have a slope of negative 2. So we're going to be able to plot the y-intercept at 0, and then we'll use the slope, rise over run, to get to the next point. So we're treating that slope as negative 2 over 1, rise over run. So we're going to go down 2 with a rise of negative 2 and right 1. That'll get me to a second point on the line. We're going to connect those 2 points with a dashed line. Remember, we want to indicate that the boundary is not included. We'll draw that boundary line with a dashed line. Now that we've done the boundary line, we want to do the shading. Now the shading, we have this boundary line dividing up the space, dividing up the plane into two parts. One side of that boundary line will contain ordered pairs that are the solution and that make the inequality true, and the other side will include points that make the inequality false and are not solutions. We need to distinguish which side is which. So we're going to choose a test point. And most people like to choose 0, 0 as a test point. However, we do have one rule with our test point, that it cannot fall on the line. And this line contains the point 0, 0, so we can't use that test point. So I'll pick a different test point. I'll pick the ordered pair 1, 1. And we're going to substitute that test point of 1, 1 into the inequality y is less than negative 2x. That gives me the statement 1 is less than negative 2 times 1. That's 1 is less than negative 2, and that's a false statement. So what that tells me is that on this side that contains the test point, we got a false statement, and all of the ordered pairs on that side will be false. The other side will have ordered pairs that make the inequality true. We want to shade the true side. I'm going to shade that whole side. All of these ordered pairs will make that first inequality true. Now we want to do the same thing for the second inequality. The second inequality is y is greater than negative 7x. We'll start off with the boundary. That boundary is y is equal to negative 7x. And once again, our inequality does not include the equal to, so our boundary should not be included in the solution set. So we will draw that boundary line dashed. Our boundary line y equals negative 7x is also in slope-intercept form. We have a y-intercept of 0 and a slope of negative 7. So we can plot our y-intercept at 0, 0. We're going to go down 7 and right 1 using the slope to get to another point. That's the rise over run. So we go down 7 and over 1, getting us right here. We'll connect those 2 points with a dashed line. We've got our boundary line. Of y equals negative 7. And now we want to figure out the shading. We're going to choose a test point. We're not allowed to choose 0, 0. We could, once again, choose the test point 1, 1. We're going to substitute that into the inequality y is greater than negative 7x to get the statement 1 is greater than negative 7 times 1. 1 is greater than negative 7 is a true statement. And so this time, my test point of 1, 1 was true. And so that means all of the ordered pairs on that side of the line will also give true statements when substituted into the inequality. I'm going to choose a different color to shade with so we don't get confused. And I'm going to shade that side of our line that contains the test point. So now I've graphed each of these inequalities individually, and we want to talk about the solution to the system as a whole. Now, solutions to the system will be ordered pairs that make both inequalities true. So what I'm looking for is the overlap of these two regions that I've drawn. And we can see that in this section right here, you have shading from yellow and shading of orange. That is where the two regions overlapped. And we would use these boundaries here to trap that region. The boundaries are not included because they are dashed. So this region here is the only region that would be included as the solution to the system. Thank you for checking out my videos. Have a great day.